This simple animated video will teach you how to tell a well-constructed VTL from one that may be too light for your needs. When you're shopping, we hope it helps you to root out both inferior machines and ones that cost more but don't actually give you more. And we trust that the more you know, the more you'll agree with us that Momentum is better built than the majority of VTL brands, irrespective of their price. We'll start by peeling away the sheet metal and other items so that you can see the essential parts of this MVL-16 model, as well as those of a generic model, both having 63-inch diameter tables. This generic machine is no specific brand, but it incorporates commonly used construction, so it may resemble some that you have seen. First, let's look at the overall structure typical of a heavy-duty machine such as this MVL-16. Shown are some of the key dimensions for this model. No need to write them down because they're all in our literature or on our website. But these elements are massive. We'll zoom in on one component as an example. The MVL-16's standard ram is 9.44 inches square. Larger rams are optional. The bigger the ram, the more rigid. By comparison, here's the structure of a typical lighter VTL. One reason that this machine is cheaper to produce is that its critical parts are smaller. Its ram thickness is only 8.66 inches. That saves money, but it also gives 30% less inertia for rigidity. Check ram size when evaluating machines. It makes a good point of dimensional comparison because it is almost always disclosed in VTL specifications. The MVL features a full wrap, arc-shaped column. Full wrap means that it curves all the way around the table. This maximizes mass, rigidity, and dampening. Arc-shaped refers to the face nearest to the table. This shape best absorbs cutting loads. By contrast, this is a cantilevered design. Far from being a full wrap, it barely extends to the table center line. It's half the mass of the MVL's column, and so provides less rigidity and dampening. What's more, the face isn't arced. This design saves cost, but it isn't what you want for demanding work. To confirm column construction, look at casting photos. Or check a machine's weight. One weighing half to 2/3 of the MVL doesn't have a full wrap column. The MVL is a full rail machine. This means that the cross rail extends fully to both sides of the spindle center. The MVL-16's full rail permits 40 inches of travel in the negative X direction. This allows you to probe parts on their diameters and to use one tool for ID and OD work, simply by reversing the spindle. By contrast, this is a half rail machine. You'll notice that the ram barely reaches the spindle center line. With a half rail, you can't probe parts on their diameters, and you certainly can't use the same tool for OD and ID work. To see if a machine has a full or half rail, check its X-axis travel spec. If negative X is about the same as positive X, it's a full rail machine. But if it is just a few inches, it's a half rail machine. Less expensive, but with compromises. Raising the cross rail moves all of the mass of the rail, saddle, and ram. The MVL uses hydraulics for lifting and counterbalancing, and hydraulics to clamp the guideways and pin vertical position once the rail is in place. Two rack and pinion sets, synchronized by a torsion bar, ensure level movement. All of this provides reliable elevation and locking year after year. Less reliable approaches include using a ball screw instead of a pair of hydraulic cylinders to move the cross rail, foregoing counterbalancing, and/or skipping the synchronized rack and pinion system. Confirm that hydraulic cylinders, a counterbalancing method, and a synchronized rack and pinion system are all present when evaluating a VTL. The MVL's saddle is a single piece and extra long. The saddle holds the ram, so making it from a single casting adds cutting rigidity. And extending its length well above the crossrail gives the most ram support, again, maximizing rigidity. A single piece, extended length saddle is what you want. This machine has a two-piece saddle. Bolting it together is less costly, but can compromise rigidity. The example also shows a short saddle. Notice that it doesn't extend past the crossrail. Again, this saves money, but costs rigidity. It's easy to confirm a single-piece, full-length saddle from machine pictures. You should not see bolted halves, and you should see the saddle extend well above the rail. The MVL and similar caliber VTLs use an automatic tool changer that stands bolted to the floor. This allows the longest and the heaviest tools as a standard, and it enables easy fitting of extended size options. The cheaper approach is to hang the ATC from the rail, but this requires the weight of the entire tool magazine to raise with the rail. It limits standard tool length and mass, and it makes fitting larger options difficult. When evaluating a VTL, confirm visually that the tool magazine is bolted to the floor, not hanging off the crossrail. A heavy-duty powertrain has a few elements. First, a reinforced belt transmits power from the motor to the gearbox. During crashes, it may help reduce damage to expensive gears. Second, the gearbox is specifically built for the purpose and features oversized components. Third, all gears have helical teeth for smooth power transmission. These elements create a long-lasting powertrain. Lighter and less expensive approaches include omitting the belt, leaving the gears unprotected during crashes. Using an off-the-shelf planetary gearbox, which entails undersized gears, and using straight as opposed to helical teeth. You'll commonly find these attributes on machines with less horsepower. But even coupled to the smaller motors, these powertrains don't stand the test of time as well. The literature for better-built machines should clearly reveal the approach to power transmission. If not, ask the salesperson to disclose it, including pictures. The MVL's linear axis motors are equipped with gear reduction to transmit maximum torque through heavy feeds. Note the gearbox on this X-axis motor. This is another routine place to save cost on lighter VTLs. On this machine, no gearbox is present, just a motor, coupling, and bearing. Checking is easy. Looking at a picture of an axis motor, just confirm that you can clearly see a gearbox between the motor and its ball screw. A heavy-duty VTL, such as the MVL, has two sets of spindle bearings. A dedicated thrust bearing takes the gravitational force on the workpiece and the table. A separate radial bearing handles rotational and cutting forces. Then, the entire spindle assembly is pre-tensioned. This approach maximizes part capacity, rigidity, and spindle life. Some machines skimp by using just one combo bearing of a cross-roller type. That lowers the allowable table load. It's a sign of a lighter spindle, likely to wear out sooner. An easy way to confirm spindle bearing robustness is to check maximum workpiece weight. For a 48-inch table, it should be at least 17,000 pounds. For a 63-inch table, it should be 22,000 pounds. A lesser spec means just one bearing instead of two. The previous chapter is a good segue to three final specs that tell you a lot about a VTL: machine weight, maximum part weight, and horsepower. An MVL-16 weighs 78,000 pounds. All of that iron resists cutting forces in a way that lighter designs just can't. As mentioned, it will handle 22,000 pounds. Even if you never need that, it means a longer lasting machine. And it has 75 horsepower standard. More power removes metal faster. There are VTLs asking higher prices that weigh half or 2/3 of what an MVL does, handle a 17,000 pound part, and have just 60 horsepower. They clearly don't give you more, they just cost you more. These three key parameters are easy to check in published specifications. Reviewing them is a smart way to compare VTL capabilities and build quality. We hope that this video helps you separate the wheat from the chaff when it comes to VTL construction quality. Taking a couple of minutes to confirm each point above can help you avoid settling for an inferior machine or paying a big premium for a heavily advertised brand that doesn't actually give you more. And we trust that when you do so, you'll appreciate that Momentum gives you far more for your money than does any other choice. And please contact us if you would like assistance in benchmarking any other VTLs that you may be considering, or for general application assistance regarding your vertical turning needs.